if we don't have a transition, that will be later moved as a dummy state, and we have to but still mention, because this is we are going to convert it as DFA. So this will be our new state. So if we combine here Q0 Q0, we can see from this one also Q0 and Q1 by 0, while it is going Q0 and Q1. If we like union all this thing, it is Q0 Q0 Q1, so it will be Q0 Q1. So now we have 3 state with 2 final state, because our previous final state was Q1. So both of these will be final state here. So this is initial state and both of these are final state. So if we Q0, these are the diagram. This diagram is also incompleted, because by 1 we have mentioned here, but we have forgot to mention this summation. So we will be here, we can write here a dummy state, so it will be going to summation or dummy. We can represent it in this way. That will be our 4th column actually. 1 2 3 and 4. This is our 4th state. So we can write here a dummy state here. From this one we will move to 0. For this transition we have to present here, and this will be our 0 and 1. So now this diagram is completed. So this is conversion from NFA to DFA. So this is an example that you can try at home, they say, for converting NFA to DFA. Now coming to epsilon NFA, why we need epsilon NFA, that is the prime question. Suppose we have a regular grammar or language having a to the power n, b to the power m, and c to the power, suppose m and o or q, having n, m and q, all these are greater than 0. Suppose we have this one. For this one, is it, first question is, it is regular? Of course it is regular, because we don't need to care about what is the number, like is it equal or not, we don't need to think, because these are all individuals that it can be represented as a self loop. Now if we consider this one, so this is a simple machine. Still if we design a DFA, how to design a DFA? So it can have, suppose we are starting with A, because whenever we will be getting in, so it can have n number of A. So in n it can have no element, right, because we have given here as 0. Whenever we are mentioning 0, whenever we are mentioning here 0, that means that it can or cannot have, this language can have null, it can have only A, it can have only B, it can have only C, it can have AB, and then anything like BC or CA or anything it can have. So only for null, that initial state will be final state. Now for n number of A we can represent it here. Now here is the question. Now we have already defined it A. Now here we can go with a B, and this one is for B, like at least one B it will be accepting, and sorry, we have 3 input alphabet, right, A, B and C. So the next alphabet, if it is only C, then also it has to be accepted. So this will be our next state, and it can have only C. Now any number of B is coming, it can accept. We can move from here, that is B and C can also be accepted, and any number of C it can be accepted. Now if it is DFA, now this minimum transition is completed. Now we need to care about this string state has all the strings. Here it is B and C but no A. So if we give A here, what will be the problem? It will accept the string with A, B, A also, but it is not allowed, because we have to consider it is, we don't need to count, but thing is that we have to all A, then we can have all number of B's, and then we have to have all number of C's. So for this one, for A we have to go to a dummy state. For this one, for B and A also, because C we have, for A and B we have to go to a dummy state. So this is the DFA for this diagram. But we need to think of lot of things, like what we have to consider here. That is a question here also, what we will be putting, whether A or B or something, and also this dummy state. So initially if there is large number of variables, then it is a complex problem. The same problem can be solved with epsilon NFA. We don't need to care about anything. Suppose we have an A, we have number of B, and we have number of C. So because all these are self loop, we can give it in this way. It is accepting anything also, like nothing, then also it is accepting. So we can design an NFA with epsilon in this way. So this is a simple epsilon move diagram, epsilon NFA. So this is the same power having this DFA, and it is working also, this working also same. Whenever we don't know anything like how much cost it is needed by which we can move to one state to another state, in that time we can put an epsilon. By epsilon means we can imagine it as we don't need any cost, so but we can move it easily, like we don't need to pass any string. So the definition here we have seen. Now this is the definition. This is del. Now it is perfectly working for epsilon move also, that is del q into summation union q, union epsilon, because now in this last figure we have seen without moving, giving any input also we can move to from one state to another state. So that is an example of epsilon NFA with epsilon. So now by giving input epsilon also we can move now, and how many states we can move? Obviously this state will be 2 to the power q. So if we consider now we have an NFA, in the last diagram we have seen that we have a DFA and NFA. Now we also we can say that this is, suppose this is the NFA, that NFA in definition we say that NFA, DFA and epsilon NFA, all these are equivalent, like logically equivalent. We have already proved that a DFA is by default an NFA, or by default can be considered as epsilon NFA. We have seen that a NFA can be converted to DFA. The same thing we can do, we can convert an epsilon NFA to NFA, then as we already have NFA to DFA, then we can have all the machines like we can prove, we can say that this epsilon NFA or NFA is also equivalent. That means that NFA, DFA and epsilon NFA on this are equivalent. Now if we consider the same machine, we can see here this is the same machine, that is A with epsilon, A number of B and C number of A, B and C. The same question we have with a set of A, B and C. These are the input symbols, and we have a state Q as equal to Q0, Q1 and Q2. This is an NFA with epsilon state. So first thing which we have to consider for converting an epsilon NFA to NFA, first we have to find the epsilon closure. Epsilon closure, what is epsilon closure? Epsilon closure is nothing but it is a state, like a union of all the states by which we can move by epsilon. Now if we check with Q0, from Q0 where we can go by epsilon? We can go to the state itself, right, by epsilon, because without anything also we can travel to the own state. Now with epsilon we can go to Q1 as well and Q2 also. So these are the states by which we can move by epsilon from Q0, and these are called as epsilon closure of Q0. Now if we consider for Q1, we can't move from Q1 to Q2 because there is no Q1 to Q0 because there is no arrow, but from Q1 we can move to, this is not possible, but from Q1 we can move to any state, this own state, that is Q0, Q1 and Q2. So these are epsilon closure of Q1 and Q2. Now epsilon closure of Q2 is Q2. Now to convert this machine we need a formula that will be as epsilon closure of del of epsilon closure of a state into input alphabet. We can write here as any input alphabet, and this will be the state transition from this state. Suppose for this one, for Q0 we can go to with 0 and 1, right. For Q0 to, we have seen Q0 having epsilon transition as Q0, Q1 and Q2. We can mention it here Q1 as Q1 and Q2, and Q2 as Q2 only. Now if we check for this one, what we have by Q0, if we need to find this Q1 with 0, Q0 with 0, that means first we have to epsilon closure and all the transitions of epsilon closure of Q0 with 0. This is the complete thing we have to consider. For this one, first we need to know what is the epsilon closure of Q0. So we have Q0, Q1 and Q2. With this one we need to consider with 0 on del. We have to identify this one and then again we have to find the E closure